In 5.5, we're going to find the absolute extrema from various candidates. Remember, extrema is the extreme points or the absolute maximums and minimums. Okay, so if you recall from before the extreme value theorem, if a function is continuous on a closed interval, then there exists a maximum and a minimum on that interval. Okay, of note, extreme values refer to the absolute maximum or minimum value as opposed to the local minimums or maximums. They can occur at the endpoints of the domain or at the relative extrema. There can only be one maximum or minimum value, but they can occur multiple times. When they say they want you to find the maximum or the minimum, they actually want you to think of the y value. But that same y value can occur multiple times at different x values. Okay, now the way they want you to find the absolute extrema is what they call the candidates test. Okay, and this can be used to find the absolute extrema on I'm going to say a closed interval. It needs to be closed so you can include the endpoints. So we're going to find all the critical numbers and the endpoints, and we're going to evaluate the function at each of these points. The largest y value is going to be the absolute maximum, and the smallest y value will be the absolute minimum. Okay, so let's go ahead and look at example 1. Example 1 says find the absolute maximum and minimum values. So I'm going to start off by finding the derivative just like we've been doing to find the critical numbers. Okay, the critical numbers occur when f prime equals to 0 or when f prime is undefined. So let me set this equal to 0. I'm going to factor out the 3x. Now x equals 0 and x equals 2 are the two critical numbers I found so far. And they are both between -1/2 and 4. So I'm going to include both of them. Now f prime is, there are no values at which f prime does not exist. So x equals 0 and x equals 2 are the only critical numbers. Okay, I found the critical numbers. The endpoints are -1/2 and 4. I'm going to evaluate the function at each of these points. Okay, so I need to figure out f of 0, f of 2, and then also the endpoint. So f of -1/2 and f of 4. And among these, I should be able to figure out the maximum and minimum values. Okay, so let me go ahead and plug in 0. 0 minus 0 plus 1 is 1. What is this? 8 minus... No, I can't do it in my head. 8 minus 12 plus 1 is -3. If I do -1/2, -1/2 cubed is -1/8. Minus 3 times 1/4, so 3/4 plus 1. Let me think about this. If I make this over 8, -1/8 minus 6/8 is -7/8, and the -7/8 plus 8/8 is 1/8. And then f of 4 is 64 minus 3 times 16 plus 1, so I'm going to get 17. Okay, so I evaluated the function at the endpoints and the critical numbers. The largest y value is the maximum, the smallest y value is the minimum. So the largest one is this one. The smallest one, that one. Okay, so I'm going to go ahead and answer the question. So if absolute maximum is 17, and they want the actual output value for the absolute maximum, we normally write where it's located. It occurred when x is 4, and the absolute minimum value was the -3, and it occurred when x equals 2. Okay, let's do one more example. Okay, this is a thinking example. Okay, so for example 2, we are given a graph of f prime of x. So this is f prime. I'm going to find the relative maximums and minimums and absolute maximums and minimums to the best of my ability. We're mostly going to think about this graph, and in the future we'll examine it more. Okay, so let me see. If it is a relative minimum, I know that occurs when, hold on, let me think. Minimum is when f prime is going from negative to positive. So let me see, when is f prime going from negative to positive? Positive to negative, negative to positive. So right here, the graph is going from negative, the f prime is going from negative to positive. So there is a relative minimum at x equals 3, negative to positive. Now at this point here, it's just sitting there and it starts going positive. So that's one of those points where some people would consider that a relative minimum and some would not. So if you choose to include x equals negative 3, that's fine too. You don't have to include it though, because it's kind of undefined on one side, so it's a little bit of a gray area. But the reason I would include it is because if I start with a slope of 0 and then the slope goes positive, then this point must be lower than the points on the right. Okay, let's still think about a relative maximum. If it's a relative maximum, f prime is going from positive to negative. So f prime was positive to negative right here. Okay, is there any other places? Now again, there's that one point that is controversial, but we'll go there. Okay, so if I go from x equals 4, the slope is positive, and then it just stops. So some people consider that to be a relative maximum. It would be like, hold on, come here, pencil. Okay, it goes up and then it just stops. So you can see why you would consider that a relative maximum, but it's one of those things where some people consider it and some people don't. So if you include it, that's fine. If you don't, that's fine too. Okay, now the question is, can we figure out where there's an absolute maximum and an absolute minimum? This one requires, we're going to kind of think about it and we're figure out a more formal way in the future. Okay, so if I start here, f prime is 0. And then f prime is positive all the way from this x equals negative 3 to x equals 1, which means for this whole section of graph, there's a positive slope. So this is going positive from x equals 3 to x equals 1. It's not linear, but it is going up, 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 that whole entire time. Now when it gets to x equals 1, it goes down. And even here, it still has a negative slope all the way to 3. Now I'm going to sketch that it's going down. I'm not going to worry about how it's actually going down. So it's going down some way. It's not linear, but I'm just going to look at it to see so I can think about the maximum or minimum. Okay, and then from 3 to 4, it starts going uphill again, but only for 1 unit of x time. So maybe something like this. Okay, so based on just looking at that, my best guess for an absolute maximum would be that it happens right here. So I'm going to say the absolute maximum looks like it happens at x equals 1. Now, how about an absolute minimum? Is it here? Because this is low, but this point is lower. So way over here, it's even lower. So I'm going to say the absolute minimum most likely occurs at x equals negative 3.